Welcome to this tutorial which covers connecting to the WaveShaper A-series instruments and how to generate basic filter functions using the WaveShaper app or your web browser. The information in this tutorial applies to all WaveShaper A-series models, including both benchtop and OEM versions. The rear of the WaveShaper A-series has both USB and Ethernet connectors. USB connectivity provides backward compatibility with previous versions of the Wave Manager software, version 2.7.3 and above, as well as supporting existing user-written software that uses the USB interface. Ethernet is our preferred internet interface going forward, and this is what we'll focus on for the rest of the tutorial. There are two ways to connect to the WaveShaper using the Ethernet port. A direct connection, as shown here, where the WaveShaper is plugged straight into an Ethernet port on your computer, or a network connection, where both the WaveShaper and the computer are connected to the same network. When connected to a network, you can control multiple WaveShapers in a single session, or alternatively, multiple computers can connect to and control a single WaveShaper. When connecting to a network, it is best to plug the WaveShaper into the network first before powering it up, as this ensures that it correctly obtains an IP address from the server. For the remainder of this tutorial, we'll be looking at this configuration where we have two WaveShapers, a 4000 and a 16000A, connected to an Ethernet network with a single PC controller. To connect to a WaveShaper when using a Windows-based PC, launch the WaveShaper app. This opens the WaveShaper Connect program, which scans for connected WaveShapers. As you can see, I'm currently connected to a network, and the WaveShaper Connect program has found these two WaveShapers. For each of the WaveShapers it finds, it shows the model number, the serial number, and the IP address. You can now connect to the WaveShaper either through a browser or through the WaveShaper app. I'll talk more about connecting via a browser later, and for now we'll focus on using the WaveShaper app, which is our recommended way of controlling a WaveShaper from a Windows PC. As I mentioned previously, it is important to note that for a reliable connection, you must connect the WaveShaper to the network before turning it on. Now, should you need help at any time, the WaveShaper Connect program and the WaveShaper app contain multiple sources of help. These include a detailed help manual, a copy of the Quick Start Guide that is provided with every WaveShaper when it's shipped, and a link to the WaveShaper and Wave Analyzer online knowledge base. A soft copy of the full WaveShaper manual is available by selecting Help, which provides full information on all aspects of the WaveShaper. A copy of the Quick Start Guide is also available. This provides simple instructions for getting your WaveShaper up and running. Finally, there is a link to the online WaveShaper and Wave Analyzer knowledge base. This is an online resource where we provide additional information about the WaveShaper and Wave Analyzer. It's a great place to find hints and tips about using your WaveShaper. Connecting to a WaveShaper is as simple as clicking on the Connect button. I'm going to connect to this 4000A and we'll use that for the remainder of this demonstration. And for clarity here, I'm going to expand this to fill the whole screen. The WaveShaper control interface is divided into a number of regions for ease of use. On the left-hand side is the selector bar, which allows you to select the type of functionality that you want to use. Adjacent to the selector bar is the control panel, which allows you to control the optical parameters of the WaveShaper, the filter shape, and so on. The controls available in the control panel will vary depending on the choice of functionality made in the selector bar. At the top of the screen is the button bar, which contains a number of shortcut buttons as well as the controls for the graphical display. You'll note that right at the top it also tells you which WaveShaper you're connected to, in this case WaveShaper 200527, which is a 4000A. The main part of the screen is taken up with a graphical display of the current optical configuration of the WaveShaper. We'll now look at each of these in turn as we use them to program and control a simple filter function. Looking firstly at the selector bar, the top set of icons allow you to select the way in which you control the WaveShaper. We're focusing today on the simple filtering capability, whilst the other control types will be addressed in separate videos. The icons on the selector bar towards the bottom of the screen are the Tools control and the Help control. The Tools function allows you to select the units that the WaveShaper works in, either wavelength or frequency, as well as providing access to detailed settings and error logging functions. The Help function provides access to the soft copy of the help manual as seen earlier. So let's go back to the basic filter control that we're going to be using. Before we jump in and start setting up a filter, I'd like to explain what the graphs on the screen are showing us and the functions available in the button bar, as we'll be using these to understand what the filters look like. When the WaveShaper app starts up, there are 4 graphs visible as we see here. The 2 graphs on the left are a preview of the optical function that you're going to upload to the WaveShaper. The top graph shows the amplitude function and the bottom graph the phase function. Having this preview capability allows you to see what your filter function looks like before uploading it to the WaveShaper. The 2 graphs on the right show the filter that is currently uploaded to the WaveShaper, again with the amplitude in the top graph and with the phase below. Now we know what we're looking at in the graphs, we'll take a quick look at the shortcut button bar before we take the controls to create a filter. The shortcut buttons are here. The first 2 are the undo and redo buttons, which operate as you'd expect in a Windows application. The transmit button sets the WaveShaper to transmit all wavelengths from the input to the designated output port. This is useful to quickly set the WaveShaper to a known state, particularly when creating channel dropping filters. Conversely, the block all button sets the WaveShaper to block all incoming signals. This is particularly useful for setting the WaveShaper to a defined state before creating transmission filters. And then finally here there is the Save button, which, as the name suggests, allows you to save the current filter shape so that you can quickly reload it at a later time. As you can see, the control panel has 4 controls. The shape, which controls the basic filter shape. Control, which allows you to control the optical properties of the filter. This is used particularly for the basic filter shape. Advanced, which allows you to create complex filter profiles by combining multiple filter shapes to make, for instance, comb filters or interleavers. And the Apply button, which, when clicked, uploads the filter shown in the preview graphs to the WaveShaper. So, to set up a filter, you first prepare the filter shape that you want using these controls, then press the Apply button to upload the filter to the WaveShaper. Starting with the shape control, there are 3 predefined filter shapes built into the WaveShaper. Band pass, as we see here, a band stop, and as you see in the preview, that changes to a band stop function, and a Gaussian, which creates a Gaussian pass filter. In each case, the preview graph changes to show which filter is selected. We're going to focus here on a simple band pass filter. The values in the control section can now be modified as you wish. So first I'm going to change the center frequency, which is currently 193.5 terahertz, to 194.1 terahertz. And as you can see, the preview graphs change to reflect that change in center frequency. But as I have not yet pressed apply, we have not uploaded that to the filter to the WaveShaper. I can then also change the filter bandwidth. At the moment this is 100 gigahertz, 0.1 terahertz. I'm going to change that to 247 gigahertz or 0.247 terahertz. And as you can see, the filter bandwidth in the preview expands to reflect this change. Note that both the center frequency and bandwidth are settable in 1 gigahertz increments. I can also introduce attenuation into the filter. And what I'm going to do here is put in, for the sake of this demonstration, 4.1 dBs attenuation, and you can see that the preview graph shows that we've added some attenuation in there. The attenuation is programmable from the interface in 0.1 dB steps. This filter is now the one that I want to upload to the WaveShaper, so I press Apply to do this. Uploading the filter typically takes around half a second, and you can see that the current graphs on the right hand side now show the filter having been uploaded to the WaveShaper and being active on the WaveShaper. I'm not going to talk about phase in this demonstration. That's covered in the advanced filter functions, which we will talk about in a separate tutorial. But I will talk briefly about the port control. This allows you to select which output port the signal is sent to. In the graphing, the output port is indicated by the color of the line on the graph. Currently, we've set the output to port 1, and I can switch the output to port 2 by selecting port 2 here. You'll see that the graph changes to being green, and then clicking apply. And now the output is green, which is the color for port 2. You'll notice when I did the drop down that there is also this port called block. The block port is a dummy port, often referred to as port 0, which is generally used in conjunction with the advanced filtering capability to optimize the performance of complex filters containing multiple bandpass and bandstop region. As I said, for the phase control, we will not be talking about this block capability or the advanced capability here, as these will be covered in a separate video on the generation of complex filter shapes. Okay, now that we've seen how to create and upload a filter, let's look in a little bit more detail at what's happening in the graphing pane and how we control what's going on there. We've talked about the colors being representative of different ports, but let's see what else we can do in here. So we're going to look now at these graphing controls up here in the top right. Looking first at these pan and zoom buttons. As the name suggests, clicking on the zoom button changes the cursor to a magnifying glass in the graphing region and allows you to zoom in on any part of the graph by drawing a box around it, like so. To do this, you start in the top left-hand corner and draw down to the right. Note that the scale, the x-axis scale on both the amplitude and the phase change at the same rate, so that you can see the correlation between phase and amplitude if you're using the phase control. Notice you can also zoom in both dimensions, both in the wavelength and also in the amplitude. So I'm just going to zoom primarily on the amplitude here, and now you can look just at the top corner here of the curve. Now, to return the axes back to their default values, just click and drag up to the left, and the graph then resets to its default values. The pan button changes the cursor to a hand and allows you to drag the graph around in any direction that you like, so that you can again focus in on particular parts of the graph. To reset the graph to its original location, click again on zoom, drag up and to the left in the same way that you did previously. The final button allows you to select which graphs are shown and what information is shown on the graphs that are displayed. The top section here allows you to select which ports are displayed on the graphs. The default is to show all ports, but for complex filter functions across multiple ports, or for WaveShapers with large numbers of ports like the 16000A, this can become confusing. So it is possible to hide some of the traces so that you only see the ones of interest. So by selecting which traces to see here, we can now just see the trace for port 2, which is the port that we have the filter set to. And the port numbering here shows you which color graph and which color line on the graph applies to the graphs that you can see. The selector boxes below this section, labeled phase and preview, allow you to customize which graphs you can see. By default, all the graphs are visible, but it's possible to hide the phase graphs by deselecting phase, so that we only see the amplitude spectra. Similarly, it's possible to hide the preview just by deselecting preview, so that we only see what is currently shown on the WaveShaper. And again, we can bring back the phase for that and bring back the preview as well. As I mentioned earlier, you can also control the A-series WaveShaper by using a browser. So let's take a quick look at how that works. Firstly, I'll close this WaveShaper app that we've been using so far. And now, instead of clicking on Connect in the WaveShaper Connect, I'll choose to Open in Browser. What you'll see here is that the interface is identical to that in the WaveShaper app for Windows. And you can see the same controls for filter generation and control as you described earlier in this tutorial. Where the browser is particularly useful though is in controlling the WaveShaper from a non-Windows computer, including from Macs, Linux, and from mobile devices. In fact, you can control a WaveShaper from any device that can run a web browser simply by typing in the IP address of the WaveShaper you want to connect to in the address bar. As an example of control from a non-Windows computer, here's a screenshot of an Android tablet, in this case a Google Nexus, controlling a WaveShaper from within a Chrome browser. The tablet connected to the WaveShaper through a Wi-Fi router. Similarly, here's a screenshot of an iPad controlling a WaveShaper from within Safari. In both cases, the connection is made by simply typing the WaveShaper IP address into the address bar of the browser. So, to summarize, in this tutorial, we have learned how to connect to the WaveShaper from a PC using the WaveShaper app and from a mobile device using the instrument's IP address. We've looked at the basic functionality of the WaveShaper app interface. We've learned how to set up simple filters using the inbuilt filter functions and how to control their basic properties such as center frequency, bandwidth, and attenuation. And we've learned how to control a WaveShaper from within a web browser for both Windows and non-Windows controllers. For more information, please see the WaveShaper manual, which is installed as part of the WaveShaper app, or also check out the Finisar knowledge base at www.finisarknowledgebase.com. Thank you.